All right, here we are. We're in chapter 2, first section. So this chapter has a lot to do with geometry and measuring things. This particular section talks about measuring two-dimensional figures in different ways or three-dimensional figures in different ways. So maybe before we start, I was thinking maybe we can talk about just the difference between one-dimensional figures, two-dimensional figures, and three-dimensional figures. So I heard it described, I think it was by the astrophysicist Neil deGrasse Tyson. He said, if you can measure something, or if you can describe how large or small something is with one measurement, so for example, the length of a string or the length of a pencil or something like that, that would be one-dimensional because all you have to specify is one length. So for example, from here to there, it could be, 1.5 inches. So I would say, 1.5 inches from here to here. And that's all I need to specify. That's how you know it's a one-dimensional object. And there's not a lot of options there. It's probably just a line segment. If it had any thickness at all, this line that I drew, that's now a two-dimensional object. So it's not very interesting, and that's why we don't even talk about it in this section. You don't hear a lot of mention of one-dimensional figures. Two-dimensional, though, of course we could see those. Those are, kind of flat figures. But if I have a rectangle, for example, the one I drew here, if someone said, well, how big is the rectangle? Or other figures too, circles, triangles. If someone wanted to know how big it was, I'd have to specify two numbers. I couldn't just say, oh, look, the length from here to here is 2, inches or feet, whatever you want to say, or centimeters. I'll just say feet. If I said, oh, it's 2 feet wide, and then someone would say, okay, yeah, that kind of describes this rectangle, but how tall is it? I have to specify another height. Oh, it's 4 feet tall, for example. That would describe it totally. Someone would know exactly what that rectangle looks like. Oh, okay, it's 2 feet wide and 1.4 feet tall. Okay. So that's how you know it's a two-dimensional figure. And then on the other hand, a three-dimensional figure, it would be something that, it's hard to draw, of course, on a flat paper or a flat computer like this. But you'd have to specify 3 just to pretend I'm a good artist, okay? I'm trying to pretend that too. But let's say it's, 9 centimeters wide, I guess, and then maybe 2 centimeters tall. Sorry, it's so tiny. Let me try to zoom in on it here. So if I said, I have this box at my house, and someone says, oh, can I have that box? How big is it? I'd say, let's say it's 9 centimeters wide and 2 centimeters tall. That doesn't really describe it very well. They'd say, well, how deep is it? I can imagine this face. You described one face of the box or the three-dimensional figure, but you didn't really tell me how deep it is. I want to know if this box is something I would want. Is it going to hold the stuff that I want it to hold? So you have to give them one more dimension. Maybe it's 1 centimeter deep or something like that. Whatever number. That would fully describe this three-dimensional figure. So that's how you know it's a three-dimensional figure that has to have 3 measurements to fully describe it and stuff. Anyway, that made a lot of sense to me. So if you're ever not sure how many dimensions a figure has, that's how you know. So it looks like on this page that we're looking at, I'm just seeing two-dimensional figures here. This guy, it's some kind of weird shape that's not filled in. Same thing with, this guy is filled in, but it's a weird shape, but it's two-dimensional because it's flat it's not just a line, but it's flat on the page. It's not, it's not something that's popping out at me, a third dimension kind of thing. So the first measurement we're going to look at in this section is perimeter. So the perimeter of a two-dimensional figure, we wouldn't talk about the perimeter of a three-dimensional figure or the perimeter of a one-dimensional figure. It doesn't really make a lot of sense. So the perimeter of a two-dimensional figure is the sum of the lengths of the sides of the figure. So remember, sum, that's one of those math words that, they throw around, but sometimes it's easy to forget what that means. That just means you're adding them. So you're adding all the lengths of the sides of the figure. So let's see if I focus on this very leftmost example here. It's asking us to find the perimeter of this shape. So I would go, okay. It kind of helps me too because this figure in particular, for example, it's showing some of the measurements of the sides, but it's not showing all of them. So it looks like they're specifying this distance here, which is nice, and then this distance here, this distance here, this distance here, but I don't know this distance from here to here. And then that last long leg of the perimeter, I don't know that either. So there are some things I won't know, but I think I can kind of infer them, which is nice. But I always imagine a little person starting, again, they could start wherever, but I just, for some reason, this corner called to me. They're going to go for a walk. And they say, all right, I'm going to walk this direction. Although where you start on the figure and which direction you start going doesn't matter. But I'd say, well, how long or how far is this little person going to walk? Well, first they're going to walk the 6 centimeters to get to the other side of this first leg of the shape. It's like a city block. This person's walking around a city block that's really weird shaped. So at first they're walking 6 centimeters, but they're also then going to walk, this looks like this is 4 centimeters. And of course, all this math can be done in your head, but it's kind of nice to have it written down so later, if you come back, you can always refer to it. And then plus another 2 centimeters, it looks like, to make it across this kind of weird little corner here. And then I'm going to go, this little person's going to walk down 3 centimeters to get to the bottom of this figure. And then it looks like a little more. Now this is where I got to think about it. What is this number? Because this person's going to walk that distance now. So I'm thinking you got to kind of infer it. Imagine I complete this big rectangle here, a square. Yeah, it's a rectangle, huh? So this whole distance across from here all the way to over here should be 6, because it should match this side. I mean, I didn't probably draw it very nicely, but it's supposed to be as wide as the top is. So I guess this thing I'm looking for is 6, a little bit less than 6. How much less than 6? Well, the part you're missing is this here. 2 centimeters was the distance from here to here, which should be the same as here to here. So if this is 2, let me do a different color. That would make it a little more simple, maybe. This distance is 2, and the entire distance is 6. The difference between them must be what I'm looking for. This is 4 centimeters. 6, take away 2. Yeah, because the entire width of this figure that I kind of extended with these dashed lines was 6, but take away the 2 that's not actually there. That must be what's left. So, okay, that's what I was missing. 4, I'm going to write that here. 4 centimeters is where he walks next. And then we've got one more part of the trip to get all the way around this block. But that's another number that they didn't give us. So we got to think about that. What's that number? Well, looks like, the left side distance vertically should be the same as the right side distance vertically. This entire distance is what I'm looking for. The same number as this side. It should be this 4 centimeters plus the 3 centimeters here. I think that's what we're looking for, because it's kind of, the vertical is broken up into 2 parts. It looks like they said this is 4 basically about here. If I match this side. And this was 3, so together it must be 4 plus 3, 7 centimeters here. 4 plus 3. There we go. That was the last number we were missing. So if you're ever given a homework problem or a quiz problem, whatever, and it looks like there are some numbers missing, you're saying, wait, how am I going to find the perimeter if there are numbers missing? That must mean that you can infer what the numbers are using the given numbers. So anyway, let's see what this all adds up to. 6 plus 4 is 10, plus 2 more is 12, plus 3 more is 15, plus 4 is 19, plus 7 is, why can't I do that? 26, wow. Centimeters. Wait, now I feel like I did that wrong. 11, 16. Yeah, okay. Why? I don't know why it's the simple math, supposedly, that I feel like I make mistakes on. Just adding and multiplying, that kind of stuff. So I think that's it. That's his perimeter. Okay, now they want us to do the same for this other figure over here. And it looks like there are no numbers given, but this whole thing is kind of sitting on a grid. And it looks like they're trying to say that each little square of this grid is 1 centimeter wide or tall. And it looks like, yeah, so each of these, this is 1 centimeter. And this is also 1 centimeter. So they don't really need to specify how tall or how long this figure is at each little part. We can infer it just based on it sitting on this grid. So I'm gonna place, and don't feel free not to have to draw it's not like you have to draw this little person. When you take your exam, you say, well, I don't want to lose points. I better draw this little person here. No, you don't have to do this. Okay, it's just something silly that helps me remember it. So, and you can, like I said, start the little person wherever you want and walk in any direction. It doesn't really matter. It's up to you. I don't know why I always make the little person walk clockwise. But okay, vertically, how far are they going? 1, 2, 3, 4, 5 centimeters, it looks like. Okay, so imagine they'd be at this corner down here, and then they'd be walking this many. I'm just counting from each, this grid. So from here to here is 1, from here to here is 2, 3, 4, 5. Okay, like that. And then I'm counting here 1, 2, 3. So it looks like This little person's walked 5 centimeters. And I don't know why these two examples both have centimeters. It could be any, measurement length or measurement unit. They just happen to have the same one. So this person's walked 5 centimeters, 3 centimeters. Now they're going to turn around and go around this corner and walk, looks like another 3 centimeters, huh? To get from this distance to this distance, that's 3 of those squares to walk. Okay. And now walking this direction, this inner part, let's see, that looks like 4 centimeters, I think. Because it's 4 of these little squares that they're walking across. Okay. This is a lot of walking for this person. Okay, now 2 to get from here to here. 2 centimeters. Got it. And now 2 more centimeters to get from kind of around to the very far side of this figure. 2 centimeters. Now this is not the last part. That's why it's kind of good I drew that little person for myself, because I might forget where I started. In the last figure, I started the person here in this corner. But why did I change it? I don't know. Just for funsies, to confuse myself, because life is boring, and confusing myself makes it more fun. I don't know. But what length is this side? 4 again, huh? 1, 2, 3, 4. Okay, so they're walking the 4 centimeters to get to that top left corner, but the person didn't start there. I don't know why I made my life harder. They started way over here. How many centimeters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9? Does that seem right? 1, 2, 3, 4, 5, yeah, okay. Wow, that's a lot of numbers to add together. Awesome. Let's see, how many is that? 5, 8, 9, 10, 11, 15, 16, 17, 18, 19, 23, plus 9 is 32. Wow. See, you can even be a math teacher and not be good at math. 9, 13, 14, 15, 16, 17, 21, 24. Plus 8. Yeah, I think that's it. All right. Don't make fun of me if I'm wrong, okay? Please. Not to my face anyway. All right, looks good so far. I think we're good to go. I always try to box my answers too. I think I've mentioned that before. Just in case, whoever's grading my quiz or my exam or whatever might say, they might accidentally think they see the answer somewhere else, but I'm saying, no, the rest of that is just work. It's not actual answers. Okay, now they got this weird H kind of shape here. But same kind of thing, I'm going to do the same thing. And I like how it's just written out for me. I don't have to figure out the lengths, most of it. Doesn't matter where you start, but I have to draw a little person there so I don't forget where I started and where I ended. It doesn't matter what direction I go, but I'm gonna write, okay, he's walking that direction, 4 centimeters plus, now down, looks like another 4 centimeters. Now to the right, 5, oh, sorry, dang it. I think because the last two, the last two had centimeters. I'm just used to centimeters now, but these are just meters, regular meters, okay. And clearly, I know before you say it, these pictures are obviously not to scale, right? Meters are much wider than this, but pretend. We're just, suspending our disbelief. Now then, they would start walking this direction, kind of upward from our vantage point. There's no number there, but I'm imagining these two lengths, this length and this length, they look the same. So whatever this length was, in this case, 4 meters, I'm pretty sure this is also 4 meters. So I can kind of infer that. Okay, now they're walking 4 meters. And then they would turn the corner and walk. This looks like 3 meters. Ooh, running out of room here. Oh, man. And now they're going to walk down all the way here. Whatever that length is, they haven't told it to me, but I can see across the way. This distance is 12 meters, which looks, I'm pretty sure it's the same as this distance, right? The length on the left side is the same as the length on the right side, so I can infer that this is the same here. Okay, so 12 to get to the bottom of this figure. Now they're going down at the very bottom of the right side of this H figure that doesn't have a number, but kind of same thing. I think it's the same as this guy up here, 3 meters. All right, I'm going to add that before I forget. And then I'll go up this direction. It doesn't have a number, but it looks like it's the same as this guy over here. That's 5 meters. I better write that down before I forget as part of my work. Oh my gosh, this person is doing too much. They're walking so much. Okay, this direction, at the very kind of middle bottom of the H, I don't have a number, but it looks like it's the same as this here, right? 5 meters, so I'm going to add that. Lots of meters. This person is getting their steps in today. And then we'll go down this direction. It looks like that was the one that was actually given, huh? 5 meters. Oh my goodness. I think I'm going to need a calculator for this. 5 meters, huh? And then this direction here, That doesn't have a number, but it looks like, yeah, it's the same as this guy up here. I got 4 meters. I think this will be 4 meters also. We're almost in the home stretch now. I better write that 4 down before I forget. And then we'll go walk the last leg of this trip. Whew, and then that person's going to go home and take a nap because they are tired, I think. All right. Oh, I'm going to mess this up for sure. There's too many numbers, but we do what we can. Okay, we got 4 plus 4, 8 plus 5 is 13, right? Yes. 13 plus 4 is 17, plus 3 is 20. 20 plus 12 is 32, plus 3 is 35, plus 5 is 40, plus another 5 is 45, plus another 5 is 50, plus 4 is 54, plus 12 is, don't tell me, 66. That's a bad omen, huh? Meters? Did I do that right? Well, we're in it to win it now. 31, 30, 60. Yeah, okay. I think that's good. That looks good. That's my answer. That was, oh, wow. And now look at this guy. This seems so much easier. It's just straightforward. This is like a regular city block someone might walk around. I like this one. Why didn't this one come first, huh? This one should have been there first. All right. So I'm going to walk whatever direction this looks like. Okay, 14.5 feet. Got it. Feet. Now where are we going? I'm going to go down around this corner. It looks like they said that length is 7.5 feet. Gotcha. And now we'll go across the bottom. It doesn't have a distance, but I mean, it looks pretty much the same. I'm no measurement expert as the top part, 14.5 feet. That must be the distance we're walking now. Okay, the last leg of the trip is this one. It doesn't, it's not written that it has some actual length, but it looks the same as this side. So it looks like it's going to be 7.5 feet. All right, last part, 7.5 feet. All right. Sounds good. Now I have to add these together. And when there's decimals, don't feel bad about using a calculator. There's no shame. I got no shame like that. But to me, it's easier to add the like ones. 14.5 and 14.5 is 29. And then 7.5 and 7.5 is 15. There we go. I'm going to add those together now. And that's in feet, of course, feet. Feet, that would be, let's see, 44, I believe. I'm no math major, but I'm pretty sure that's the one. All right. So far, it's pretty good. I mean, sometimes you have to kind of think, well, this is the distance that I'm walking, but I don't have that. I don't see it in front of me. Is there a way to get it? But now we're coming to circles. I'm going to have to think about this because it's not obvious how far you're walking. I mean, it would be nice if someone gave me a circle. They said, oh, here's a circle. And the distance around it, if they told me the distance around it is blah, that would be nice. But usually that's not it. Maybe they'll give you either the radius, which is the distance right from the center to the outside, or the diameter, which is the distance through the middle but all the way across. As you kind of see in this figure here, it's nice. So it's kind of got a good, a visual reference. So the circumference there's just another word for perimeter. Circumference is like this. See, it says here, find the perimeter, which is just circumference of a circle. Circles are so special. They got to have their own name for everything, and then like I said, the radius is the distance from the center to that any part of the circle. And then the diameter is the distance across the circle right through the center. So anyway, the perimeter of a circle, there's a little formula for it. As you've seen this number pi before. Pi is that, that decimal that goes on forever. It's 3.1415, it goes on, But just for our purposes here, just to keep it simple, I'm going to use pi as 3.14. Just keep it simple. We don't have to go too crazy with it. But there are actually two kind of different formulas for it, which seems confusing at first, but it's good because it kind of depends what you're given. The perimeter of a circle can either be 2 pi, so it's just the number 2, and then multiplied by pi, which we're going to get from this guy, 3.14. So those are just numbers we know already, and then multiplied by the radius, if that's what's given. But on the other hand, if you're not given the radius, you're given the diameter, it's just pi times the diameter instead. And that's because the diameter is 2 times the radius. If you think about it, right? Diameter is the distance all the way across the circle. The radius is half of that. So the diameter is 2 times the radius. That's why. You can pretty much what you're doing is you're replacing 2r with d for distance here. So it's the same formula. It's just like, well, what are you given? Are you given r, or are you given the distance? Yeah. So anyway, let's put it to use on these little examples down here. Find the perimeter of the following circles, give an exact answer and an approximate answer. Okay. So and then just in case you're not familiar with types of problems like this, when they say an exact answer, what they mean is just leave pi, that symbol in your answer. You don't need to replace it with 3.14, you know? So that's what they mean by exact answer. But when they say approximate, that means use a calculator with, 3.14 for pi. Replace it and then use your calculator to multiply it to get your answer. Okay, so you notice in these two examples, I've got the left one, I've got the right one over here. One of them is, I'm given the diameter, the one on the left. Diameter. So I'm going to be using the second kind of formula up here for perimeter. It's just pi multiplied by the diameter. But in this other example on the right side, I'm given the radius, which I can tell because they're only giving me the distance across half the circle, not the entire distance across. So I'm going to use, when I actually do this problem, the other formula up here, the 2 pi r. But, what you could do is if you just kind of don't want to worry about two formulas, you can just memorize one, kind of like, for example, this one, because it's nice and simple. So I could have done, in this right example, when I go for it, I could say, well, this is the radius. What would the diameter be? Diameter would just be 2 times the radius, or 2 times 28, which is 56. And then you could plug that in. So it's not like you have to worry about two formulas. You can always use one. Just anytime you're given the radius, you could just multiply it by 2 to get the diameter. But it's up to you. I won't make you memorize these formulas. These will be on the on the exam itself. So, because I figure in real life, if you're in a situation where you have to find the area of a circle, you can probably just go look up the formula. You don't have to memorize it. It's kind of silly. This section's mostly teaching or kind of testing you on, do you know how to find these things if you're given the formula, not memorizing. That's why I like math. It's not as much memorizing. Anyway, perimeter is pi multiplied by the diameter. But here the diameter is 12, so I'm going to put that here. 12, and it should be in inches, this thing. And that's really it. So that's actually the exact answer is nice because that's all you got. It's 12 times pi. And usually, if you have pi multiplied by something, usually we try to put pi on the right side and the number on the left side. Almost like if you remember in algebra, if you saw x as a variable multiplied by 12, you wouldn't leave it like that. Oh, my answer is x12. Now, it just sounds wrong. You want to put x, the variable, on the right side. That's more like it. So it's kind of similar to that, even though pi is not a variable. We know exactly what pi is. It still just looks nicer because it looks a lot like a variable. Anyway, so that's my exact answer. I didn't really have to do a whole lot of work. Just stick the number that I was given here, 12, next to pi, bada bing, bada boom. And that's it. But approximate answer, okay, this is where I actually have to do some calculations. I'm going to, kind of like they mentioned in the directions here, I'm going to replace pi with 3.14. It'll be in inches. And I'm going to put that in my calculator. What's 12 multiplied by 3.14? And my calculator tells me it's 37.68. Oh, you know what? Yeah, no, I'm good. I'm confusing myself again because life is boring when you don't confuse yourself. There we go. So it depends kind of like on an exam. It should specify not just find the perimeter, but I want the perimeter and it has to be exact or approximated. It'll tell you, or it'll ask for both. Yeah. So, okay, how about this other circle here? Just for fun, since we have the other formula sitting there, I'm going to use this one. We got perimeter is 2 pi r, just kind of so we know what each one feels like. The radius of this circle given was 28 meters. So it's going to be 2 multiplied by pi multiplied by 28. But at that point, if I want to find the exact perimeter, my answer is going to have pi in it. So it's going to be something pi, and then I'm measuring in meters, so I'll put the meters there. But I guess the pi is something I don't want to mess with because I want to keep it exact. Let's see, I'm going to put 2 multiplied by 28. What would that be? 56. Didn't we just do that one? There we go. So even though the pi is there, you can still multiply the numbers that are, yeah, you're able to multiply. But now I want approximate, so that's all I have to do is replace pi with 3.14 and multiply with my calculator. So I'm going to go, it was 56 multiplied by now 3.14. All right, let's see what that is. Whoops. 56 multiplied by 3.14, it's about, or no, not about, 175.84 meters. So this might be something you already knew, but the reason that this is exact and this is approximate is because even though my calculator just told me it's exactly 175.84, it's an approximation because pi isn't really 3.14, it's more than that, it's 3.1415, and the decimal goes on forever, so this isn't really exactly the right answer. It should probably similar, it's probably like 175.84 dot 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 dot, or maybe 175.85 dot dot dot. So I think for most real life situations, like if you're an engineer and you need to figure out the perimeter of a circle because maybe you have a pipe you're trying to let flow or water flow through, something like that, and you want to know, well, what's the perimeter for some reason? This is probably close enough for any purposes in real life, but math people love exact answers. This is probably for math people. If you're a weirdo, I might like me. And then this is more practical, you know, engineers. How do you spell engineer? There you go. I can't even spell it. See, good thing I'm not an engineer. I can't even spell it. Yeah. So that's, yeah. Anyway, it's just math people and physics people. They like exact answers as well. All right. Now we're coming to, sorry, this these formulas are a little fuzzy. Now we're looking at area. So this is a two-dimensional, or it's a measurement of a two-dimensional figure, but the area of a two-dimensional figure is the measure of the region within the boundaries of the figure, inside. So far we talked about perimeter of rectangles and stuff like that, and that was the measurement of outside. Even the circles we were just looking at, the perimeter of those, it would be like if someone's walking around. If I was a person, and I started here, and I walked all the way around, how far did I walk? Well, that was the perimeter that we used, 2 pi r, or just pi times the diameter. But the area is how much. It's kind of a measurement, yeah, of how much is inside of a circle, or what's the measurement of the inside. Whereas the perimeter is more of a measure of the outside, or the very edges of it. You know what I mean? Yeah. So what would be the difference? It would be like, if this is like a pool, a circular pool or a sauna or something that people are swimming in. I guess how far I walked around it is the perimeter, but how much, what's the area of the surface of the water? How much water is on the surface? That would be the area, kind of. And unfortunately, every figure has a different formula for the area, and it's not like I can just kind of imagine the person walking around, or imagine, a situation and just add a bunch of stuff. Like with perimeter, it's a little harder than that. But luckily, you don't have to memorize any formulas. It's just kind of, if you had this formula sheet in front of you, would you know how to use it and when to use it? So maybe I'll just talk about all the figures here. We got a square. The formula for the area of a square is just the side length to the second power. So S would be the length. It doesn't really specify what it is. It's the length of not just a side, the side. I mean, all the sides are the same, it looks like, in a square, right? So this is length S, this is length S, this is S. Whatever it is, it could be 5, it could be 10, it could be 1,000,000, whatever it is, multiply that by itself. And then for a rectangle, we got rectangle. It's almost like a square, but you can't say, all the sides are the same. So the area formula is length times width. So let's say, and it doesn't really matter which one's which. For some reason, I always think the horizontal is length and the vertical is width, but you can switch those. It doesn't really matter. You just take the dimension, with the measurement of one dimension and the measurement of the other dimension, and multiply them. Length. So you just say L is length and W is width. There, that's it. Easy peasy. So that's not bad. Now the next one, a triangle. These are getting a little more complicated as we go, it seems like. For a triangle, it's a little more complicated. It's 1/2 multiplied by base times height. And if that's really fuzzy, maybe it would help for me to write it again. 1/2 base times height. So that, And base and height are very similar to length and width. Base and height. So maybe if we just kind of visualize what it looks like. I'm sorry if this is hard on the eyes. The height of the triangle is kind of self-explanatory, which is why the H is good, H for height. The base is just kind of how wide it is. Yeah, and the reason for the half is because I've multiplied base times height. That would be the area of a rectangle that has B as its base length and H as its height. That's a rectangle. I want a square, which happens to be exactly half the measure, which is kind of interesting, huh? Like, this is my triangle. If I want this area, it's exactly half of the area of the rectangle, which is kind of cool. If you're a math nerd, anyway. So anyway, that's that formula. We'll put all these to use, too. I just want to talk about each one. The circle, here he is. He's always making things more complicated. He's always inviting pi. You know, do you have any friends like that where you invite them, hey, do you want to come hang out or whatever? And they're like, oh, yeah, I'm going to bring so-and-so. Why do you always got to bring so-and-so? Can you just come without them? Is that like your emotional support person? Yes. For circles, pi is their emotional support person. They will always be there with them. Their best buddy. Pi, why are you always coming to the party? Anytime there's a round figure, pi wants to be there. I don't know. It's kind of annoying, really, honestly. But anyway, that's neither here nor there. Pi, and then r, that's very hard to read. I'm sorry about that. R squared. So again, pi is that thing. It's just a number. It's not a variable. It looks like a variable, right? But it's about, I should put a little squiggly equal sign, because that means approximately, not exactly. 3.14, da-da-da, and r is the radius. So this one, in this formula, we don't want diameter. We want radius. If you're given the diameter, though, you can just, take half of it. So r is the radius. And just remember that radius, if you're given diameter, just figure out what half of that diameter is, and then you'll have the radius. And you can plug that in instead. So we'll cross that bridge when we get there, right? Don't worry about it right now. The next one, parallelogram, is probably less common, but anyway, what is a parallelogram? I guess it's like a rectangle that got maybe a strong wind blew it over a little bit. Pretend like I'm drawing straight lines. It's not very great. Oh gosh, that's so bad. There we go, that's better, huh? Look at that, that's beautiful. Anyway, I'm pretending, it's supposed to be that this side is parallel, let's see. This side is parallel to this side, and this side is parallel to this side. Maybe there are no 90-degree angles inside of it, but all the opposite sides are parallel to each other, which is why they call it a parallelogram. But anyway, it turns out it's the same area formula as a rectangle. If your one length of this thing is b for base, but the height has to be, that's the thing about parallelograms, the height has to be perpendicular to the base. So I wouldn't want to know this distance from here to here, this kind of diagonal side distance. I would actually have to know the height, which is, perpendicular. This has to be a 90-degree angle. So, okay, so same, if you're wondering what the heck, that's the same formula as the rectangle pretty much, except now we're calling it base and height, where before we called it length and width. Base, and then H is height. Yeah. Probably the less common of the formulas are coming now. They're trapezoid, which is, basically a rectangle that doesn't necessarily have its sides parallel like the parallelogram. That formula is, oh Lord, it's so complicated. Why? Half area is 1/2, parentheses, has to be parentheses, A plus B times H. Oh my gosh. Anyway, what are A and B? A and B are the lengths of the sides that are not the same width, if that makes sense. Like this here, that's the distance from across on the top, A, and then clearly the opposite distance that's parallel to that, but it's definitely a different distance, is B, and then height has to be, just like we said, it has to be perpendicular or a 90-degree angle to those sides. So this is a 90-degree angle here. But if the way I think of it, it's kind of similar to like base times height, the area of a parallelogram, but because in a parallelogram, the distance across the top and the distance across the bottom are the exact same. That's why it works just base times height. But with a trapezoid, the distance across the top, or depending how this is oriented, but one of the distances is smaller. This one, for example, A, is smaller than B. So kind of what you're doing is you're taking the average of A and B. So how do you take the average of two numbers? You add them together and then divide by 2. And that's really what's going on here. The most of the formula is that. The average of those two lengths, you add them together, take half of that or divide by 2, Whatever that average is, now you multiply it by the height. Which is kind of, anyway, that's kind of interesting, but don't worry about memorizing these formulas, okay? Just know how to use them. And then the ellipse is sort of a similar thing. Ellipse is like an oval, basically. You know, when we were kids, we called it an oval. Now we're all grown-ups and we call it an ellipse because, come on. It's just pi multiplied by a multiplied by b, but what the heck are a and b? They're just pretty much the kind of like an ellipse doesn't have one radius, it has two radii. Because if I go from the center to maybe the left side or the right side, if I go horizontally, that's one number, whatever it is. But from the middle to the top, it's a different number. It's something smaller in this case. Maybe in other ellipses or ovals, it would be different. So it's just the two radii kind of. I mean, we don't call them radii because, yeah, I guess an ellipse has two different measurements as far as that. But yeah, it's just multiply the two kind of radii, multiply that by pi, bada bing, bada boom, 0.14, we'll do that. Yeah, so but like I said, it's kind of overwhelming, and I think if I were a student, I'd be kind of stressed looking at all these formulas. But just keep in mind, you don't have to memorize these formulas, just look at the picture you're given and then come up and match, okay, well, which shape do I have? Okay, I have this, and then bring the formula down and then plug in what you need. Yeah, it seems scary, but I don't know. I'll just go ahead and start with this top left one here. Find the area. Okay, I want to find the area of this rectangle. So I'll just go over, like if this is on my exam or on my homework, I'll go back to my formulas that should be there. Okay, it looks like I'm looking at this formula, the second one down, and it looks like it's A equals L times W. That's the first thing I'm going to do. Even if I don't know what the heck I'm doing, at least I know which formula to use. Okay, and this is where, like I think I mentioned earlier, that length, it doesn't matter which one's length. You could say length is 9 and the width is 4, or you can switch them. If someone says, yeah, length is 9, width is 4, and their friend says, no, length isn't 9, length is 4, and width is 9. It doesn't matter, it's going to end up being the same thing, you know? Depending which way you do it, either I'm putting 9 there and 4 here, or switch them, it doesn't matter when you multiply, they're the same thing. But one thing I should mention before we kind of get too deep into the numbers and move on to the next example and stuff, maybe I should even put a little note here, note that area is measured in what we call square units. So whereas perimeter, you know, if you were measuring everything in meters, your answer would be in meters. If you were measuring everything in, I don't know, inches, your answer would be in inches. But ours, instead of just regular units, we're going to have, so for example, inches squared or square inches. Square. You can either write it out, the word square, and then the word inches or meters, whatever measurement you're given, or just write it with the little 2 at the top, the superscript 2. So that's one thing I got to keep in mind, and it's, I guess the reasoning for it is it's kind of like, for example, with this rectangle problem we're doing, the 9 is measured in inches, so it's 9 inches multiplied by 4 inches, and we haven't done that with perimeter. Perimeter was always adding, although with the circle we multiplied by pi, but we never multiplied two numbers that were measuring units with perimeter, but now we are. It's 9 inches multiplied by 4 inches, so you can almost think of it as, I'm multiplying the numbers, 9 times 4, okay, that's 36. And then the units you're actually multiplying together as well. What's inches multiplied by inches? It's inches times itself, or inches squared. That's one way you can think of it. So if you're ever confused and if you're like, you know what, I don't know which units to use. Is my answer going to be in inches? Is it going to be in inches squared? What am I going to have? Just include the units in your work, I guess, and then you could see, well, inches times inches, it's kind of like x times x. I would write x squared, kind of like that in a way. So it's, yeah, kind of confusing, but I think if you have any kind of real life experience with measuring things, then you might already know that. Yeah, for example, if you had a house you want to cover in carpet, you'd measure, okay, well, how long is a room in your house. I want to cover it in carpet. I'd measure one side. Okay, this is 4, it wouldn't be inches, it would be something else, but whatever. And then the other measurement is 9. Well, how much carpet do I need? Of course, when you go to the store and buy it, they're going to say, how many square feet is your room? Or how many square, I don't know, meters? whatever. That's what it would be in, right? You probably have heard that, and you probably already know that. But just in case, it's worth saying, yeah. So that's what you're finding, the area inside. All right, how about, I think that sounds good. Hopefully that explained it. Now that this triangle, this one's tricky. I found this picture and I said, ooh, this is a good one, because this one would throw me off as a student. I'd say, wait, why are they giving me so many damn numbers? That's the question here. Sorry, excuse my French. First, okay, before I confuse myself any more than I have to, let me go up to the formulas. Okay, where do we have, Is there a triangle here? Can the triangle please stand up? Here we are. This is the triangle. I'm gonna bring that formula down. Half base times height. Okay. Before I even know what I'm doing, at least I can write the formula. You know what? If you have no idea what you're doing, you write the correct formula there. Even if you don't use it, at least you get some kind of credit for that on an exam. I'll say, you know what? They had the idea. They had the formula there. But which ones of these are base and which ones are height? So it looks like, it's not obvious. This one looks like it's height. Just by the definition of height, it's usually a vertical distance, right? So I'm thinking that's height. But then which one is the base? They gave us 3 more numbers, 9. They did that on purpose to throw us off. That's very thoughtful of them. Thanks, guys. Just keep in mind, base and height have to be perpendicular to each other or make a 90-degree angle together. Base and that'll tell us which one to use. Must be perpendicular. What a long word. So I think that should tell me. I got my height is here, 7 meters. The only one of these distances that's left between the 9 meters, the 11 meters, and the 14 that's perpendicular to it is the distance across on the bottom, the 14. So I'm not really choosing the 14 because it's at the bottom. I'm choosing it because it's perpendicular to the height they gave me. If they had given me something weird, which I don't think I would do that to you guys. I don't know. Yeah, no. I'm just trying to think if it was given a different way, if they give us this distance is, 3, and this one's 5, and this one's 4, and this one's 7, or something like that. I would use 3 for the height, but 7 for the base. Even though he's not the bottom number, he's the only number that's perpendicular or, makes a 90-degree angle with that height. So that's just something to keep in mind. I don't think that'll happen too often, but, maybe if you take another math class, they might throw that at us on accident. Okay, so now we know base and height have to be perpendicular. So I've got the 1/2, that's just a fixed number. Now base, which one did we say base was? Oh yeah, the 14. So I'm gonna put 14 meters there. And then the height, let's see, base is 14. Height is gonna be, what did we say? Oh yeah, 7 meters. There we go. Okay, and you can kind of do that in stages, I think. I'm gonna actually bring that over here, down here. 1/2, would I write 14 meters, 7 meters? The 3 numbers I'm multiplying together, you can kind of do it however you want. For some reason, I always feel like it's easier to do the whole numbers first and then worry about the 1/2 later. But what's 14 multiplied by 7? Let's see, 98, I think. And now I already know because it's meters multiplied by meters. Let's see here. 2 meters, they multiply together to make meters squared. I just have to take half of 98. What's half of 98? 49, I think. Right? Yeah. Meters squared. There we go. That's the one. Yeah, and it's not, these types of problems, it's not really easy to check your answer. It's almost like to check your answer, you just have to do the whole problem again, which is not very fun. That's not a nice thing to think about. But, what are you going to do? What was it? Oh, yeah. The other thing I was going to say is, let's see. I think as a student, I might be thinking, I don't know why this came to me. Hopefully this helps. We had, here we had meters multiplied by meters, so I wrote meters squared. And if I were a student, I might think, wait, didn't we do that before and we didn't write meters squared, like on the last section or the last part? Because there were a lot of units running around. For example, here we were looking at perimeter. There's a bunch of meters, but we never wrote meters squared or meters to a power. But that's because we were adding all the units. It wasn't meters multiplied by meters or inches multiplied by inches. It was just adding meters plus meters plus meters plus meters. If they're all adding, the unit doesn't change. It's multiplying. That's when the unit changes to square meters or cubic meters if we're looking at volume. that kind of stuff. Okay. So hopefully that helps. All right, now it looks like we're looking at a circle. And if I look back at my formula sheet, or the formulas above, I think we got pi r squared is our formula. And notice that underneath the circle we want the area and then we want the approximate area. So I think the first one's I'm gonna have pi in my answer. And the second one, we're gonna wanna replace pi with 3.14 and then figure it out on the calculator. So first I'll leave pi there, but it looks like they gave me the radius. It's 5 millimeters. 5 millimeters. Don't forget the square. Okay, then pi. Now it's kind of like I'm squaring the 5, but I'm also squaring the millimeters as well. 25 millimeters squared, which is kind of nuts. And that answer right there is fine for the exact answer, actually. Yeah, that's fine. But usually, like we mentioned with perimeter, I'd write the number on the left and then the pi on the right. Although pi is a number, but you know what I mean, the whole number. And then the units usually go last. That's the last thing to do. 25 pi millimeters. And then my last thing that I would want to do is find the approximate area, which means I'm going to replace pi with 3.14. And then use my calculator to multiply that by 25. But I should still always, I think these types of problems, like if you're taking an exam or the final, and you have a problem where you're calculating formulas, make sure you have the units at the end. There should always be units. So it looks like I did 3.14 multiplied by 25. I've got 78.5. So square millimeters. Okay. Looks good. All right. I like it. Now, what do we got? Now we're looking at this very rightmost problem here on this, what we can see is a parallelogram. So if I go back to my formula sheet, I look for parallelogram. It looks like it's this formula here. It's just base times height, which is kind of crazy. And I think this was kind of, maybe this wasn't made very well, but I think what we meant to do here is that this is 8 miles. MI is probably miles, right? Yeah. I don't know why I had it way out there. Sorry. That's my fault. Otherwise, we wouldn't know how to do this. I couldn't find the area of this thing unless I was given the exact height. Because I think we mentioned that before when we were just discussing the formulas themselves. If I'm given this distance, that doesn't help me to find the area. It would help me to find the perimeter, but not the area. So luckily, area is pretty simple for parallelograms. As long as you know the height and the base. It's just base times height, just like the area of a rectangle is length times width. Okay. So then, just like we said before, base and height doesn't really matter which one's which. You could say, well, I'm going to call 8 the base and 5 the height, or vice versa. It doesn't matter because you're multiplying them, but yeah, usually vertical height you usually call h, and then base we'll call the 5. There we go. So okay, the base is which one? I just said it. Yeah, 5. And what are we measuring in miles? And we multiply by, the height was 8 miles, okay? I'm going to multiply the numbers together. 5 times 8 is 40. Why did I feel like that was wrong? I don't know. Don't worry about it. And then miles multiplied by miles squared. So 40 square miles, that's a big area. That's what this would be. So I guess that would be a huge park, but I guess that would be like if you're wondering, well, how big is this park? You know, if it's a weird shape like this, a parallelogram, then you would, figure out what the height is and the width, and then multiply them, bada bing. That's how many square miles. Or a city, maybe a city's kind of shaped weird like this. I don't know. Oh, geez. This guy got kind of shifted, but that's okay. I think what it was meant to say was from the center to this edge is 8.5 and nothing outside. Oh, well. Oh, man, what happened to this guy? Oh, no. It's good. I'm losing it. Now, the next one we're given here is, what are we talking about now? Don't tell me. Wait for it. Why am I going blank? Oh, this is a square, yeah. Oh my gosh, come on. A square! And if I look back at the formulas in that table, the area of a square is just one of the sides to the second power. That's why, for some reason when I looked at this figure, I thought, they only gave us one measurement. What's wrong with this? Oh my gosh. I made this worksheet and it's still, wow. That's all you need is one measurement. S is the side length. Okay, that's it. Area is the side length, 2.4 feet. I guess they're measuring in to the second power. I'm just replacing S with 2.4 feet. and then multiplying that. And, you know, as soon as it's decimals, don't be a hero, you know? You can use your calculator. That's what I tell myself. Don't be a hero. Math. Math is hard enough without using a calculator. 5.76, and the feet are being squared, so it's square feet. 5.76. Does that sound right? Sure. There we go. So far, so good. Okay. All right. And then the area of an ellipse, that's what they call these guys, ellipse, because it's like a circle, but it's wider than it is tall, or taller than it is wide. What was the formula for that guy again? Pi is always involved, and anything round. Pi. That's why pizza pies are round and actual pies are round. Pi times A times B. And with ellipses, the A and the B, again, just like with rectangles and stuff, they don't really matter which one's which. I guess I'll call this guy A and this guy B. But if you said the opposite, that B is 8.5 and A is 5, whatever, it doesn't matter. It's all the same. It'll give you the same answer no matter what. So I'm going to replace, I think this is another one, yeah, they're asking for the exact answer. So one answer will have the symbol pi in it, and then the other one I'll actually replace it with 3.14 and then calculate it. So okay, pi just stays there for now. A I'm going to replace with 8.5 feet, because that's what I labeled A to be. But if you, why'd I put inches? But if you said B was 8.5, I mean, the two numbers would be switched, but you'd end up with the same answer. And I said B is 5, but that's okay if you said that was 8.5. There we go. All right. So now all I can really do is multiply the numbers, the non-pi numbers. 8.5 multiplied by 5. Don't be a hero. Use my calculator for, 42.5. And then the pi I'm just going to leave as is. He could stay on the left side, but it just looks more visually appealing when he's on the right side because he's kind of like a variable. And then the feet times feet, that gives me feet squared, or square feet. Yeah, I think in math we say feet squared or something, but if in real life, if you went somewhere and said, you want to say, I want 42.5 square feet of carpet, you wouldn't say, I want 42.5 feet squared. They would say, what the heck? And you must not measure a lot of things, I guess. But now I'm going to do the approximate area, which just means I can take this guy. I've already done all the work up here. I'm not going to worry about that anymore. 42.5. I'm going to replace pi with the approximation 3.14. And then let's see, what is it? 42.5 multiplied by 3.14 gives me 133.45. And that should be measured also feet squared. There we go. So yeah, those are our two answers. And you only see that if pi was involved in the formula. Because all the other formulas we had, the answer given is the exact answer. There's no need to approximate it, but pi is what's making you have to approximate sometimes. Thanks a lot, pi. Jeez. Anyway, last one here, and then we'll talk about volume. Maybe we'll split it up into another video, right? This is enough. Enough torture for one day. Oh my gosh. So this is a trapezoid. It's not a parallelogram. Trapezoid. Yeah, like I said, a parallelogram is when opposite sides are parallel to each other. So notice, yeah, that this side, the left and the right are parallel, the top and the bottom are parallel. This one, they are not. I see that the top and the bottom are, but the left side is kind of tilting to the right on the top, and the right side is tilting to the left. They're definitely not parallel. Not parallel sides. Yeah, two of the sides are, but the other two are not. That's how I know it's not a parallelogram. Anyway, the area for a trapezoid was the one. It helped. I don't know why it helps me so much to think of it as average. I'm averaging the two sides they're across from each other, but they're way different lengths. You know, and A and B. It doesn't matter which one's which, but they're the ones that are across from each other, and they're different lengths. So you can call, I'm going to call 4A and 7B, but you could call 7A and 4B. It's just the height. Don't mess up the height, because they're saying that one's 10. I guess you always know, because this over here, this is 10, the height. Anywhere vertically is 10, so that's definitely the height. It's the two that are parallel to each other that are A and B. That's a good, maybe if you're worried about messing it up and not knowing which side is which, the sides A and B will be parallel. But even though they're parallel, it's not a parallelogram. They're different lengths. Sorry, my handwriting is bad. I swear, in real life, with not a computer, that it's pretty good, but not on the computer. Anyway, So I'm gonna maybe color code it. Color code it? Is that a thing? I'm gonna put 4 in for A, okay. And then 7 I said was B, so that's gonna go here. And then my height is 10, that's gonna go here. And then the half, he's just gonna stay exactly, it's just a number, I don't need to replace him. Half, okay, now A, what did we say A was 4? Oh, I should say inches, sorry. Inches plus 7 was B, inches. And then multiplied by height was 10 inches, okay. Maybe it would help if I erase this picture. That was just to remind that it's not a parallelogram, okay. And now we should do order of operations. I should add the numbers that are in the parentheses first. It's half, 4 plus 7 is 11. And notice because we're adding those numbers, it's not inches squared yet. The measurement inside the parentheses is still inches because I added 7 and 4, not multiplied. But it'll become square inches now. I'm multiplying. You could multiply the half first, but I like we did before. I always like to do the whole numbers first. If I can put off dealing with fractions as long as I can, that's what I'm going to do. So I'm going to leave the half there for now and multiply the 11 and the 10. That would be 110. And now the measurement, it's inches times inches. Multiplication should give me inches squared. There we go. And now I just have to find half of that, or divide by 2, whichever one. That's 55 square inches. There. Isn't half of 110 55? Yeah, I'm pretty sure. Okay, that was fun. That's pretty much it for 2-dimensional objects. Then in the next video, we'll talk about volume of 3-dimensional